Hang on, how do you get it? How can you call it vertical on the side of a ball?
Turn curvature
Three
and
coplanar
elevation,
points,
same thing.
and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It really is.
Level.
It really is.
Level.
And bam, there's the radius of the Earth.
But as someone that doesn't use water levels, is that not a good method?
So we would
say,
call
hey,
that,
I've got-
would we
I've got
call
something with
that an even elevation?
Mhm.
Even altitude, even.
Yep. So I'd expect on an even elevation, my two measuring points on my water level are going to read exactly the same when I've got them next to each other.
Okay.
I'm going to stop there because I'm now getting frustrated that you're not addressing the actual fucking question, and you seem to be going to be out of your way to be pedantic when I'm trying to make a very simple point. There you go.
I never heard
I've
that
put you a
word
link
before.
for a chorobat. And look at that. It's got the nice little plummy bits on, and that's what you establish your angle for your slope. Isn't that cool? Yeah, I'm assuming that if I've got something like a chorobat, which is something I do know about, it's the only water level that I'm familiar with. It's the only water level I've ever touched.
No,
You're not prepared to listen, Bev? I'll go away. You can go and talk to someone else.
I think
Because you've been shown the definition of level and level surface from the actual textbook.
I think you've been a good help.
You've been shown information on geodetic surveying and triangular and spherical excess. And look at that. It's got the nice little plummy bits on, and that's what you establish your angle for your slope. Isn't that cool? You've been shown all of this information repetitively, and you still deny that it exists. So I'm going to stop there because I'm now very frustrated at your pedantry.
Okay, thank you very much. You've been a great help. I didn't realise people didn't understand what a water level was. So easily, right? Sorry. I'll obviously have to do a video making it even more understandable.
Bev, I've never watched one of your videos in my life,
fantastic.
and I never will, so don't worry about it. If I want to go and actually learn about something, I'll go to an actual textbook.
Read something.
Well,
textbook about water level.
What I noticed here, the problem is if they think you're talking about flat Earth, they won't understand anything you say. You have to say, I'm not talking about the Earth right now.
Because I physically have to move that water level, then recalibrate it.
Did you say recalibrate a water level?
Yeah, well, you're going to have to make sure it's back on level, aren't you?
Recalibrate?
Bev is here. Now you're going to get it now. So the experts here.
And look at that. It's got the nice little plummy bits on, and that's what you establish your angle for your slope. Isn't that cool?
Bev is here. Now you're going to get it now. So the experts here.
Could we just get some clarity on what actually is being said?
You can go back to textbooks from the 1950s, the 1960s,
Here we go.
and they say the same thing.
So I'll read from the definitions. Level surface. A level surface is the equipotential surface of the Earth's gravity field. It is a curved surface and dendrite element of which is normal to the plumb line. Level line. Any line laying on a level surface is called a level line. This line is level to the plumb line, direction of gravity at all points. Horizontal plane. Any plane tangential to the level surface at any point is known as the horizontal plane. It is perpendicular to the plumb line, which indicates the direction of gravity. This is what they teach, Bev.
Yes.
Yeah, this is what they teach.
This is probably why
gravity.
What you've just said.
Debunk flat Earth.
What you've just said.
It's taught.
What you've just said is one of them is normal to the plumb line, and the other one is perpendicular to the plumb line. Well, guess what?
Gravity.
Guess what? Normal and plumb are the same fucking thing.
No, it's a single plumb point. So the difference is there, Bev, and this is where
normal means orthogonal, means perpendicular, means right angles, means straight lines.
I'd like to finish my point. Bev, thank you. So what I was trying to say there is that's to a single plumb line. When you're looking at the curved surface of the Earth, we're talking about multiple plumb lines. So when I'm taking a horizontal, it's perpendicular to a single plumb, is it not?
When you're taking a horizontal, you said.
Is it not?
How often do you take horizontals?
Is it not?
Or do you just do that through a book?
Is it
not taken from a single plumb line? A horizontal is established from a single plumb, not multiple.
No, a horizontal is established with a tool called a level. It doesn't, a plumb line doesn't get involved in it. No.
Oh, so you're saying that your level is not plumb?
I'm saying a water level has got fuck all to do with a plumb line.
Are you saying that your level is not plumb?
Yes, definitely. The water level doesn't need to be plumb at all.
I'm talking about an auto level or a theodolite.
I was talking about a water level. I was talking about water level because that's the most physical we can get. You're on the closest in touch with reality, right? Nobody can mess about with that. Press buttons and switch curvature on and off. You can't do that with a water level. It doesn't ever need calibrating. It calibrates itself.
Cool. So you reject surveying equipment. I agree. Okay, that's cool. You don't do that. I think you've just
got that wrong there, haven't you? Like, can we not? Well, surely everybody understands what a water level is.
How would you do a differential elevation using a water level?
You just mark the levels, right? It'd be easier with a water level. I think, anyway. I think a water level would be more accurate over larger distances.
Cheaper and quicker. No, I'm just talking about your standard 50 meters.
Oh, well, yeah. In that case, then a 100-meter water level would be better. Because you get 100 meters with the water level. And you think that would be cheaper
and easier?
In fact, you could check one with the other, couldn't you? You could almost calibrate. You could almost calibrate an auto level with a water level.
Crit, you're avoiding every single question. Do you think it would be cheaper and easier to do that than to do that over 50 meters than to use a theodolite? If I've got to do, say, 50 or 60 readings in a day.
Yeah. It'd be cheaper to a water level. It'd be cheaper. About 18 quid. Tube of water.
I'm talking about man time.
Oh. But I'm saying it's just...
You actually understand the cost of an operation, do you? I think this is probably an area you're not very good at by the sound of it.
If you would come to watch the proof,
planning and project management?
This whole conversation would be...
Do you do cost planning and project management?
For what?
For anything.
Why is that relevant?
Because I'm talking about the operational efficiency, and you don't understand.
Operational efficiency of what?
I'm now trying to establish your knowledge of this area,
or some sort of test, or you're reading books.
No,
have you read a book about cost-effective analysis of
Bev, and I'm feeling that you're not expressing your understanding.
Buying water pipes and filling them up with water?
The Earth is very flat.
Foolish. I know you're flapping.
I wouldn't hire Bev to do any surveying if I needed a job done, honestly.
I wouldn't either. I'm a carer. So, I mean, I'd be absolutely rubbish. I wouldn't be able to do it.
No. The reason I'm asking this question is for a very good reason. And that's that, to move something that is a physical thing that is over 50 meters long requires lots of people to do that. It's not easy. It's not going to be cheap, and it's not going to be very efficient.
A water level.
This is why.
I can get 400 meters on a little hose pipe reel.
This is why
50 meters is nothing.
I haven't finished my point, but thanks for over talking me, Bev. Are you going to continue to do this?
I don't know. What are you doing?
Why do you keep over talking me? I'm
sure we started off about elevation and how we measured elevation. Now we've ended up cost analysis of you buying pipe to do nothing.
I think the best thing to do, Bev, would just be to let Dross get his points out, and let's be hospitable and
I really
generous.
appreciate that. I'm trying to be nice. I really am trying to be nice with you, Bev. I really am. So, Merle, the reason I'm making this point is when you look at doing a repetitive activity, you look at the efficiency of it. This is something I do on a fucking day-to-day basis. And one of the problems you have, and the reason, I can see why I'd use a theodolite over a tool like a water level. And the reason that I would use that is I can move a theodolite quickly, I can have my sight sticks move quickly, I can take many more measurements in a day using a theodolite than I can using a water level, because I'd physically have to move that water level, then recalibrate it every fucking time I move it, and that would take more time. So therefore, it is less efficient. Therefore, this is why we use the instruments we do.
Did you say recalibrate a water level?
Yeah, well, you're going to have to make sure it's back on level, aren't you?
Recalibrate? How would you... I'm filling the water distiller up. How would you recalibrate a water level?
How would you recalibrate? Well, I'm assuming... Yeah, I'm assuming that if I've got something like a chorobat, which is something I do know about, it's the only water level that I'm familiar with. It's the only water level I've ever touched. With chorobat, I need to establish what my plumb is, so I can then establish what gradient I want to employ using that chorobat. It's the only water level that I'm familiar with. It's the only water level I've ever touched. So I need to calibrate it to level before I then set my increase in the angular elevation of the slope that I'm determining for an aqueduct. That's something I know about because I've studied that.
What about the calibration? What was that?
When you talk about leveling a water level, that's pretty breathtaking.
Yeah, but the reason is, do you know what a chorobat is, Crit?
Yeah, well, that's a position in surveying.
Dude, let's talk about the calibration.
A chorobat was a water level used by the Romans, and it was their main instrument that they used to build aqueducts. When you build an aqueduct, you want to make sure you've got a slope that's not too steep because it causes lots of wear and tear, and not too shallow because then the water won't flow and it will stagnate.
Yeah, so inch to a mile or something like that, I think they did.
And what they used the chorobat for was to determine the angle of slope.
Wow. What, of a 1 inch in a mile?
Really, really accurate. I'll go and look it up. It's a really.
You think that was done by an angle measurement? How do they calibrate it?
You can go and look it up, Bev. I can send you a link.
No, that's what you were meant to be explaining. How you calibrate a water level.
I just told you. You need to establish your plumb for the chorobat. Yeah. Once you've done that, you can then set your angle of slope.
Do you not know what a water level is?
Do you not know what a chorobat is?
Please tell me you know what a water level is.
Please tell me you know what a chorobat is, because that's what I'm talking about.
I don't know. I'll have a look that up.
I think he does foolish because one of his mates used to have that as his username. So before you go too far down that road, I think he knows exactly what.
Foolish, you tell us you know what a water level is.
There you go.
Never heard that word
you a link
before.
for a chorobat. And look at that. It's got the nice little plumby bits on, and that's what you establish your angle for your slope. Isn't that cool?
Do you know what a water level is?
You see that chorobat there? Which is a type
brilliant.
Of water level,
yeah, that's fantastic.
Which is showing the angle of the slope using those plumb lines. It's the only water level that I'm familiar with. It's the only water level I've ever touched. Yeah, isn't that now an interesting thing that disagrees with what you were saying earlier?
It's not really. Where's the water?
The water's in the table-y bit.
Okay. Not spilling out.
Nope. That's obviously just an artist's impression. Don't take that as too much reality.
Is that water on a slope?
Drawing.
Is that water on a slope? I'm just there's a water level device, and do you want to actually see one? They're fantastic. I bet you'll love it. There you go. Just a fucking tube. Foolish.
And the chorobat itself is basically 2 vertical lines at one end and a horizontal line in the middle, connected, like a handle on a suitcase.
So foolish. When I was talking about a water level, what you do is you put some water in a tube, and the water equalizes out. Equipotential, yeah? Even altitude. It's 2 points. One at each end. They're both neither higher nor lower than the other. Just 2 points. Sounds a bit like geometry. What was it? Like a straight line.
Why don't they use water levels in professional surveying?
What do you mean, professional surveying?
When you're doing professional surveying to establish elevation, I've never seen someone use a water level to do that. Most of the time when I've seen someone like, some of the big construction firms, WSP,
it's not really that practical, is it?
Brinkerhoff, Amy, those kind of guys, they all seem to be using theodolites for that.
Yeah, although it's lower tech, than the laser level and all of that.
So why do they use theodolites and not water level?
Because they're a replacement, aren't they? So you don't need to carry 100 meters of water around with you in the tube.
Because it's easier, isn't it? More efficient.
Yeah.
Yeah, which is the point that I was making 15 minutes ago, which you tried to deny.
Fantastic, but how do you calibrate a water level?
Sense.
Foolish. You were on about calibrating them. How do you do that?
You've got to verify that you've got the right amount of liquid back in your water level. You've got to make sure that it's now working correctly before you utilize it. Surely you do that check. Make sure there are no air bubbles in it. I don't know. It's the only water level that I'm familiar with. It's the only water level I've ever touched. I'm going to say that there are things that probably can do that.
It's not a calibration, though, is it?
Well, it's still a calibration. It's making sure the tool's working correctly.
That's part of it. Calibrates itself. It's like...
Yeah.
No. But let him answer. Let him answer how he would calibrate the water level.
I've just said you make sure it's working correctly. You make sure you got the right amount of liquid in. You make sure you got no air bubbles in the pipe. That's calibration. That's making sure your instrument is accurate before usage. It's the only water level that I'm familiar with. It's the only water level I've ever touched.
Accurate. That's the calibrations after the accuracy, isn't it? How do you make sure that your water level is what do you call it? Level.
By making sure there are no air bubbles in the pipe for starters.
Oh, so you just let the water do what it does naturally?
No. So calibration, Druss, is when you have like a zero or a marker, and you're setting the measurements in gradient in a grade. So how are you doing that setting so it goes back to zero?
I would start off with a position where I've got the 2 points next to each other. I'll make sure that the liquid is equal on both sides when they're right next to each other. It's the only water level that I'm familiar with. It's the only water level I've ever touched. That's a form of calibration. That takes me to my 0 point. Now I'm going to start to take those pipes away from each other to the points of observation, and now I can take my measurement. So that's a form of calibration.
Okay.
So you're saying, hold on.
So I'm establishing my 0 base to two objects next to each other, and then I'm showing the fact that is then 0.
So you're saying level is 0?
No, I'm saying that's how I would make sure that I've got a 0 on my water level. It's the only water level that I'm familiar with. It's the only water level I've ever touched.
But that would be your measurement.
I've never used the water level in my life, but that seems like a reasonable level. A reasonable method to me. Bev, would you disagree with that?
Hold on. So Sci-Fi, you hear what he just said? That he's going to calibrate it to make sure it's 0. That's the measurement.
Yeah, that's specifically what the measurement of level, right, Druss?
Yeah. That's how when Druss knows it's level, it's 0 Sci-Fi, when he's calibrated it.
Yeah, and when it's there, right, that water surface would be horizontal,
Bev,
right?
Bev,
Perpendicular to the plumb.
Bev, I'd like to ask Bev a question, because that was my guess at how I'd probably do it. Bev, what do you think of that guess?
What, with
as a method?
Water in a tube? I'd just wait until it evens out.
Yeah, there's 2 measurement points I bring right next to each other so I can compare them next to each other.
I wouldn't need to do that. I'd be absolutely certain that the water would do that no matter what. No matter how far away one end of the tube was than the other.
But as someone that doesn't use water levels, is that not a good method?
So we would call that, would we call that an even elevation? Even altitude? Even.
Yep. So I'd expect on an even elevation, my two measuring points on my water level are going to read exactly the same when I've got them next to each other.
Okay. Now, would you, because you've got 2 points there, that's very Euclidean geometry like. Would you say it's the shortest distance between those 2 points?
No, because it's going through the tube. The tube doesn't have to be dead.
No. I mean the actual level surface would be the shortest distance. Like a hydrostatic equilibrium
I
surface.
could take that at a slight angle and it wouldn't make any difference to the length if I'm a degree
an angle? No, because they'd have to be at an even altitude, right? You can't have one higher or lower than the other because the water would, it'd even itself out again, wouldn't it? The water
would show the difference in the elevation, yeah.
No, if you moved one end up or down, the water would find its own equilibrium again. There would never be a difference. But that would show the
difference in the level between point A and point B, wouldn't it?
If you measured from that point to the ground, to the surface, yeah. Because that level
point A
would...
is my reference point, point B is my differential, and now I'm going to show whether that's at the same elevation point or a higher elevation point or a lower elevation point.
The water would give you something to measure from. Right.
Yeah. So I can say if I've got my point A of my water level at position 1, and I've got my point B at position 2, so I can then say whether point B is higher or lower or level to point A.
Not of the water level, like because you're just referencing the level there, aren't you? Point A and point B.
No, I'm working out whether my point B is at a lower elevation.
Okay. So what you do is you set
up a higher elevation to point A.
But you set up the level then, and then you measure from A to the surface, and you measure from point B to the surface.
Can I do that?
Can you
just by reading the water level? Just by reading the water level, can I not determine whether point A is higher or lower than point B, or equal?
No, the water level will give you something you can measure from, right? That is becomes your datum, doesn't it?
Can I not make the deduction if the data point that if my water level is higher, equal to, or lower than where that water level starts, regardless of whether I'm measuring to the earth or not, I can just tell whether the top of that tube is higher, equal to, or lower than the tube.
No, the water in the level will equalize itself.
Yeah.
So when you look at it, you will be absolutely certain that they are both at the same level, at an even altitude. One is neither higher nor lower than the other.
Okay, so if one side is higher, then
one side won't be higher.
Point B
they will both be level.
Oh, for fuck's sake. Yes, but in the tube, I can get a reading because of where it is in the tube.
I'm not so sure you understand this, foolish.
Oh, for fuck's sake! Maybe if I could finish a point.
You've got trapped air, or you've got a pressure on there, haven't you? That's why. That would be the cause for why one is higher. That means
no. What I'm saying is that if you've got like a scale on the side of the tube, Chemo, yeah, and you've got that level. So when I'm bringing them together, I'm making sure that they're, the tops of the tube are dead level, everything, and then I'll get the same water reading across both tubes. Now, if I raise it up a little bit, yeah, that water is going to be at the same level as the other bit of water, but the scale in my tube, it's going to read at a different level. It's going to have a different reading on that tube. Yeah, because of where that water is in the physical tube itself.
Like, imagine this, right? Imagine you've got 100 foot of, or 100 meters, anything, of tube, but like, you only put 50 meters of water in it. Well, you can move the tube around as much as you want. The water's going to move and do what the water does. The water will always establish its own level.
Yeah, which means I can create a differential from that level, showing a difference in elevation.
Based
on where the water is in the actual tube itself. I don't know why this is so difficult. This seems to be really commonsensical, and I'm really concerned that I'm wrong. But you don't seem to be addressing the point. So if I've got water in this tube, and I'm looking at the water where it reaches the height in the tube itself, how many centimeters from the end of the tube it is at either end. Yeah. If it's at 5 centimeters for my first tube.
The tube's just a container for the water. The water is the measure.
But I can use that tube then as a way of measuring things, measuring the differential.
The difference from the water level, though, but the water level establishes the datum.
How much tube do I have to the other end before I hit the actual water itself?
The water is what does the work.
Can you address that specific point? Where would the water be in the tube?
Do you want me to put my camera on?
If I've got something,
I can show you what a water level is.
If I've got a water level,
I can show you how you can move the ends of the water.
Oh, Christ's sake, Bev. Bev, if I've got a water level, it's 10 feet long. Yeah, I take one. Now I notice on my point A that the water is 2 centimeters below the top of the tube. Now, and then I put them, and both of them are 2 centimeters from the top of the tube for both of them. Now, if I raise one up a bit, it's going to change how much tube there is on one side.
If you move it up above 2 centimeters, it'll piss out the other side. Yeah.
Exactly. Yeah. That's the point. But up until that 2 centimeters, I can say that, if there's 1.5 centimeters at one end and 2.5 at the other, they're not at the same level. One is of a higher elevation than the other. The other is of a lower elevation than the other. I'm talking about the top of the tube itself.
Well, I'm not. We're just talking about the water level. That's why it's called a water level, not the top of the tube above the water level.
Past the point. I'm going to stop there because I'm now getting frustrated that you're not addressing the actual fucking question, and you seem to be going to be out of your way to be pedantic when I'm trying to make a very simple point. You're not prepared to listen, Bev. I'll go away. You can go and talk to someone else. Because you've been shown the definition of level and level surface from the actual textbook.
I think you've been a good help.
You've been shown information on geodetic surveying and triangular and spherical excess. You've been shown all of this information repetitively, and you still deny that it exists. So I'm going to stop there because I'm now very frustrated at your pedantry.
Okay, thank you very much. You've been a great help. I didn't realise people didn't understand what a water level was. So easily, right? Sorry. I'll obviously have to do a video making it even more understandable.
Bev, I've never watched one of your videos in my life, and I never will. So don't worry about it. If I want to go and actually
really foolish.
I'll go to an actual textbook.
Read something. Textbook about water level.
What I noticed here, the problem is if they think you're talking about flat Earth, they won't understand anything you say. You have to say, "I'm not talking about the Earth right now."
Did you understand my point? What I was did you understand it at all, Crit?
I understand. I kind of vaguely listened. I didn't hear all the points made. I was actually.
So why are you commenting if you weren't actually paying attention? You don't know what's going on then.
Well,
I understand your point. I understood your point.
I thought it was a really simple point.
I just had like an epiphany in a way. Like a couple of years ago, I came into this room myself and was challenging the same sort of line that Bev is. And what my original argument was, there's a huge expanse in Australia called the Nullarbor Plain.
Mm-hmm.
So what I was saying was, how can the Earth be a sphere or an oblate spheroid if there's these large areas of land and water that, they're called plains? So it's like a circle with lots of flat bits.
Let's pretend curvature and elevation are the same thing, shall we? Shall we do that?
Oh.
No, it's like there's a perfect.
You've never been.
He's not doing that, Jem. He's just talking about something.
It's like
in reality,
really doing that. Yes,
there's a sphere with lots of flat bits.
He's saying because there's some flat land without any mountains or valleys, and people refer to it as flat, that means the Earth is flat.
I'm not saying that. I'm saying there are extensive areas.
Exactly right.
And this is what happened last time. That there's extensive areas of the Earth that are not displaying curvature. So it's like a sphere with lots of flat bits. I also showed cities like the city of Los Angeles, San Francisco, New York, Tokyo. All Cartesian grid lines.
I noticed you went from...
You know what they did, just to finish the point, you know what they did, Bev?
Go on.
In the end, they just called me a deluded retard who lives in his mum's basement.
Sounds about right.
That's what I was at with.
Yeah, it does sound familiar.
Notice that you went from the terrain being flat to it doesn't display curvature. So in fact, that displays that you were doing exactly what Jem said you were doing, even though you denied it.
What did I deny? Merle, let me ask you this. If you were wrong and we're right, imagine that situation. The globe is as described. There isn't a great big lie to take you away from God. And all this is just bollocks on the internet.
Mm-hmm.
I can't remember what I was going to say now.
I was waiting for it.
Yeah, what was the point? What was the point that you made before that? Remind me what you just said.
Just that the Earth.
Oh, you got called got called a retard and delusional. That was the point. Yeah.
Yeah. Okay.
So if that's true, if we imagine a situation where that's true, would it be fair to call you delusional? Why is it there any consequence if people do or do not understand geometry? How does that help you in any way?
The Earth is flat.
Sea level is a mean, because the sea level actually changes in elevation depending where it is on Earth. In one case, for instance, Antarctica, the gravity caused by the continent of Antarctica actually pulls the sea higher and closer to it.
You don't understand hydrostatic equilibrium. Equal atmospheric pressure causes a horizontal surface.
I'm talking about the fact that Antarctica is so massive, the ice in the continent, that the sea level is higher, closer to Antarctica, because of the gravitational attraction of the entire continent. Level means curved, right?
Hang on, how do you get it? How can you call it vertical on the side of a boat?
I gotta say, you're totally blowing my mind right now.
You twat.
How do we know the Earth is not flat?
We don't. It's flat. Understanding of the world in which you live, then of course the world looks flat. The world looks flat. The world looks flat.
Neil.
Bitch. You twat.
I gotta say, you're totally blowing my mind right now.
That's what I do. 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 What I do.
But I don't have much patience for anyone who denies that this challenge is real. We don't have time for a meeting of the Flat Earth Society. Flat Earth Society.
My friends, these people are so out of touch with science. You don't need to be a scientist to know that the Earth is round.
They must have been founding members of the Flat Earth Society. They would not have believed that the world was round.
Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow or it can crash.